Alright, day 3 of exponential functions. We're going to look at graphing again today, and we're going to write equations from graphs. So number 1 says identify the equation for the horizontal asymptote. We can see the horizontal asymptotes right here at y equals -4. Domains all real numbers, so from -infinity to infinity. The range is going to go from my asymptote, which is at -4, to infinity. The graph's above the graph. Okay, the graph's above the asymptote, excuse me. Horizontal shift from the parent function. Okay, we have our initial value here, and we have one up and one away, right? So these are my two parent points. Okay, so from those parent points we can see that this is basically my origin. So we shifted our origin to this point right here. So we went over 2, so the horizontal shift we went left 2 units. The vertical shift we went down 4. Okay, so this is my two parent points. We have a point with an initial value 1 unit greater than my quote-unquote origin, and then we have a point 1 up and 1 away from that. Alright, so the growth or decay, we can see that it is a growth, obviously, because it is an increasing function. So number 1, here we go, sketch the graph for each function. So we have our base of 2 raised to the x. Okay, we have a vertical stretch here, so vertical stretch by 4. So let's see what that does to the graph. Alright, so let's plot our first point. So if I plug in 0 here, so I have an x of 0. I get 2 raised to 0 is 1, so 0, 4. So we have a point at 0, and instead of being at 0, 1, which is my parent point, we're going to go up to 0, 4. So there's our point right there. Alright, now let's find another point. So let's go with 1. So 2 raised to the first power is 2, so we have a point at 1, 8. So go over to 1, go up to 8, bam, there it is. So you can see the stretch of the graph right there. What if I plug in -1? If I plug in -1, I got 2 raised to the -1, which is going to be 1/2. 1/2 times 4 is 2, so -1, +2. If I plug in -2, I get -1/4 here, times 4, that's going to be -1, so 2, -2, -1. So the graph looks like this. Exponential growth, because obviously my base is greater than 1. Same thing here, we have an exponential growth, but this is a stretch by 5. So again, let's look at what that does to the graph. So let's plug in 0. If I plug in 0, I get 1 times 5, which is 5, right? So we had a vertical stretch. We changed my initial value of 1 to now 5, so 0, 5. If I plug in 1, I've got 10, so 1, 10. I have a point at 1, 10. If I plug in -1, it's going to be -1/2. That's -5/2. If I plug in -4, that's that's 5/4, excuse me, +5/4, so 1 and 1/4. So the graph looks like this. So you can see it's going to get higher quicker, vertical stretch. Alright. Number 3, we can see that it is a decay function. 1/2 here is going to make it a decay function. My base is less than 1. So again, let's plug in our point of 0. Anything raised to 0 is 1. So we have an initial value of 0, 4. So this is my initial value here. It's an understood 1 in my parent function. Okay, if it's a change to that, okay, that's going to tell us our initial value. Alright, so from that point, 0, 4, let's find another point. So 1/2, we raise it to the first power. Let's plug in 1 for x. We've got 1/2 here. So 4 divided by 2 is 2. So we have a point at 1, 2. If I plug in 2, this would be 1/4, so it would be a point at 2, 1. If I plug in -1, that would be the reciprocal of 1/2, which would be +2. So we have a point at -1, 8. So you can see our decay function. Decay decreasing, decay decreasing. Alright, what about this 2, right? So let's plug in a 0. Let's see what the 2 does to the graph. Okay, if I plug in 0, I get 1 here, so that's going to be 0, 2. Alright, if I plug in 1, I get 1/2. 2 raised to the 1/2 is 1, so 1, 1. So you can see, again, my parent function here, bam, bam, 1 unit and 1 unit. Alright, now if I have a -1, I plug in -1, it's going to be a +2. Okay, it's going to be the reciprocal, so flip it, it's going to be 2. 2 times 2 is 4, so -1, 4. And there's your decay function there. All right, look at some stretches and let's look at some shifts, excuse me. So I can see here that obviously I have vertical stretch. I have a shift right 2 units. Okay, so from my origin, we're going to go right 2, we're going to go up 2. So my new origin, quote unquote, is going to be right there. My asymptote is going to be right there. Let me write it in pen for you to see. My asymptote is going to be at positive 2. Okay, so my new origin is here. All right, so let's look at some points, right? So for my new origin of 2, what if I plug in 2 right here? I've got 2 raised to the 0 because 2 minus 2 is 0. 2 raised to the 0 is 0. Okay, so sorry, 2 raised to the 0 is 1, excuse me. So 1 times 3 is 3 plus 2 is 5. So the point at 2, 5. So again, that initial value here, okay, so instead of it being up 1, that's going to be up 3. 1, 2, 3, bam. All right, what if I plug in 3 here? So I've got 3 minus 2 is 1, so 2 raised to the first is 2. 3 times 2 is 6, 7, 8. So I have a point at 3, 8. So you can see we had a vertical stretch, up 1, 2, 3 over 1. So instead of it going up 1 over 1, we went up 3 over 1. Bam, 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 bam. All right, what if I plug in negative 1? That's going to be negative 3 right here. Sorry, not negative 1. Let's plug in positive 1, excuse me. So it's going to be negative 1, so it's going to be the reciprocal of 2, which is 1/2. So I get 3 halves plus 4 halves, which would be 7 halves, right? Or 3 and 1/2. So positive 1, 3 and 1/2. So you can see my function is going to look like this. All right, let's look at a decay function. So again, you can see we had stretch here. We went right 1 unit, we went down 2. So we went right 1 unit, we went down 2. So my new origin, quote unquote, is going to be right there. We have our asymptote there. It's going to be a decay function, so we're going to go decreasing here. All right, so my new origin is there. So let's plot the first value we have. So if I plug in positive 1, I get 0 here. So 4 times 1 is 4. Minus 2 is 2. So I have a point at 1, 2. Okay, and again, 1, 2, 3, 4. 4 units away from that origin right there. All right, now if I plug in 2, I've got 2 minus 1 is 1. So 1/2 raised to the 1 is 1/2. So 4 divided by 2 is 2. Minus 2 is 0. So I have a point at 2, 0. It'll be an intercept. Okay. And let's get another point. What if I plug in 0 here? So if I plug in 0, I have negative 1. So 1/2 raised to the negative 1. I'm going to take the reciprocal of it, so flip it. So 4 times 2 is 8. 8 minus 2 is 6. So I have a y-intercept at 0, 6. So our decay function looks like that. All right, look at number 7 and number 8. We're going to write our equation from the graph. So again, we have y equals a b raised to the x minus h plus k. All right, we can see here that I have an asymptote right here. Okay, and that asymptote is going to be at y equals 1. Right? Yeah, asymptote is going to be at y equals 1. All right, so I know I went up 1 unit for my k, so plus 1. All right, so the base, let's look at 2 raised to the x. We did not have any horizontal shifts, so 2 raised to the x. Let's look at the a value. All right, so I have a point, if this is my origin, because we went up 1 unit, because of that asymptote right there. We have a point that's 1 unit up from that. Fantastic. That's what we want. That's our initial value. Okay, and then from there, I went up 1, 2, 3 over 1. So I have a point right there. So we could say this is 3 times 2 raised to the x plus 1. Sorry, let me backtrack. Okay, my bad. All right. So we know we have plus 1 for my asymptote here. Our parent point is 1 unit up, so that's going to indicate my a value is going to be 1, initial value. Now my base from this to this, okay, my base is up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1, okay? But now I'm going from my quote-unquote origin. So if I'm going from my origin, I'm basically going up 1, 2, 3, 4 over 1. So I have 4x. So I have y equals 4 raised to the x plus 1. Alright, let's look at number 8. Number 8, I can see that I have an asymptote at y equals -2. So y equals a b x minus h plus k. This k is going to be -2. Y equals, alright, again my parent point, 1 unit up from that, so it's going to indicate we have an a of 1. It's still a growth function, so we know we're going to have a b value that's greater than 1. We didn't move over any, so we have 1 times something raised to the x. Now let's find the something raised to the x. So we went up right here, so we have another point at +2, 7. We have another point at +2, 7. So again, we have another point at 2, 7. So from -1 or 0, -1 to 2, 7, base is going to be 3. So we have a of 1, y equals 3 raised to the x minus 2.